Okay, gonna do another relative motion. This one, if you read through it, is kind of a significant jump. So there's a lot going on in this one. It's not a pretty triangle, but we've got the math tools. Just because it's not a nice triangle doesn't mean we can't solve it. The basics of it is gonna start off the same. Since it is a little bit weirder, I'm gonna write out all the subscripty stuff. It's about a plane flying in the wind. So the velocity of the plane relative to the ground is the velocity of the plane relative to the air plus the velocity of the air relative to the ground. That's how I do my subscripts. People might do them a little bit differently, but bottom line is we should be getting this kind of pairing up to show that to kind of indicate that they cancel out. In this particular question, I know that the plane relative to the ground has to end up being west 15 degrees north. Oops, that's a little bit messy. Let's see if we can do better there. The direction of this one is west 15 north. That's what we're paying the pilot to do. That's what the pilot's got to do for us. I know that this one has got a length or a value of 400 kilometers per hour, but I don't know what direction it's actually going. I know it's going to be mostly west, but we got to deal with the wind. It's got to angle north a little bit to get to Vancouver. And finally, I know both parts of the air relative to the ground. I know all about the wind. It's blowing 70 and it's in that west 30 degrees south direction. That's enough that I could build the triangle, but having been through this before and seen some struggles with this topic before, I'm going to do a little thing first before I build the triangle. A cool thing about vector addition, like every kind of addition, is it doesn't matter what order we add our vectors in. So instead of doing 400 in some unknown direction, I'm going to replace the right side of the equal sign. I'm going to bring the 70 up to the front. So 70, I was lazy, it's kilometers per hour, west 30 degrees south, plus 400 kilometers per hour in our unknown direction. Must bring us to, I'm not sure how long the line is going to be, I'm not sure how big the vector is going to be, but the velocity of the plane relative to the ground, and it's got to be in that 15 degree angle direction. By switching it around a little bit like that, I can draw the triangle a little bit better. So to draw the triangle, I know that my final resultant from straight west is pointing 15 degrees north. So the resultant velocity has to be pointed that way. And the 15 fits in there. That's the direction of the resultant based on those other two vectors. By switching the orders, I can definitely draw that first vector. It's 70 kilometers per hour, west 30 south. So it's going to go this way. My scale might not be quite right, but this angle is the 30. And this length is the wind, so that's the 70 kilometers per hour. My second vector in my addition, the 400, has to close that triangle. The red line that I drew, that's the resultant, so it's what I get when I add the two other vectors, so I got to finish my adding. The 400 is going to be in this direction to close off the triangle. So 400 fits in there. I don't know what this angle is yet, but we'll work to get it. I don't know what this angle is yet, but I'm going to need it to move on. I do know the other angle. I don't know if I can draw that in or without messing up my diagram, but this big angle in here must be 45. It's 15. The red line was 15 above straight west. The wind is 30 below straight west, so the 30 and the 15 combine to make a 45. And I don't know this side of the triangle. The way this question is worded, I'm asked for the direction and how long the flight will take. Basically, I got to solve this triangle. If I take a look at it, I know there's a 45 in the one end, or 45 is the one angle, and I know two of the other sides. So it's been a while, but that is a sine law situation. I'm going to call this angle up here angle x. The sine of x over 70 is the sine of 45 over 400. Sine law is all about opposite angles and sides. So that's sine law. That'll tell me the angle up top. You can do the calculator work to double check, but within rounding, I got the angle up top to be 7 degrees. That tells me another interior angle, but really I'm curious about what angle the plane's got to fly, and ideally I'm going to get this angle outside relative to straight west. I got a little bit of work to get there. If I know that the top angle is 7 degrees, I know the other angle is 45, I can figure out this other, my third interior angle, they must add to 180. So it's 45 plus 7 plus y. That means y has got to be, you can double check my math, I'm getting 128 degrees. So I've just figured out the direction of the plane. It's 128 degrees away from the wind's vector, but the wind's vector was 30 degrees away from straight west, so I got a little bit of work yet to do. This angle down here, Z pattern, that's also 30 degrees. So really, I know that the plane is the 30 plus the 128, so that's 158 degrees away from east. That's a funny way to describe an angle. Instead of saying 158 degrees away from east, if I do one more subtraction, 180 degrees minus the 58 degrees, that means we're 22 degrees away from straight east. So now finally I've got the angle that I want. This angle in there is 22 degrees. So the direction that the plane has to fly is straight west, 22 degrees towards the north. So to cover a course that's 15 degrees north of straight west, because that stupid wind is pushing it to the south, it has to angle a little bit north. It's got to angle 22 degrees north. That's the first part. We now know the direction the plane must fly. The second part is how long it takes. I'm going to go back to my original triangle and do another sine law. I want to know how long it takes, I need to know the side v. Sine law, v over sine. Now I know angle y, it was 128. So v over 128, and I always go back to what's given. That's, we know the 400 and the 45. Sine law, I just put the sides on top and the angles on the bottom, so I didn't have as much, so the algebra was a little bit easier for me. When I crank that out, you guys can check, but I'm getting approximately 446, and that's in kilometers per hour. Now we're almost done. It's going 446 kilometers per hour, and it's got, let me go back and check the question. It has got 3,500 kilometers to go. That's just that simple. V equals d over t. T is going to be d divided by the v. So rearranging in my head, get d over the v. Double check my math, but within rounding, I'm getting 7.85 hours. That question was more complicated. A lot of little things with interior angles to help with the triangle. One of the main physics tricks that helped is right at the very beginning, I changed the order of the addition and took the vector that I knew both parts of. The wind, I knew the magnitude and the direction. So I flipped it so I drew that first, then I could add the plane on to the end of that. In relative motion, there's always going to be more than one way to draw the triangle. So have you gone ahead and done this and got the same answer from a slightly different triangle? You've done the right physics, you've done the right math, you just started from a different method. It's completely fine to do it the other triangle way.